Okay folks, this is a microwave, an ordinary microwave just like any other. It's not the school's, it's mine. I don't do this with the school's microwave because if I break it I'll get in trouble, but like all microwaves, this one has got a little information sticker on the back, and this information sticker contains a couple of useful things that we need to know. We are going to use this microwave to measure the speed of light. And the first bit of information I need to do that is this number written right here. It says 2,450 megahertz. So that's the frequency of the microwaves emitted by this microwave oven. That means that 2,450 million times every second this microwave goes a complete wave. It disturbs the electromagnetic field once in each of those cycles. Okay, so basically really high frequency. It changes the wavelength quite a lot in that time. Right, we are going to use a couple of small items to help us measure the speed of light with this microwave. And the first thing we're going to need is a couple of crunchy bars. Okay, got two of those. Second thing is an ordinary dinner plate. And third thing is that I've modified the microwave slightly. I've taken out the table in the middle, the bit that normally spins round. I'm putting some little glass dishes that are going to support the plate so that it's not touching that, it's not going to spin. So whatever I put in there will stay in the same position, it won't rotate at all. So these crunchy bars and this microwave is actually going to help us find out exactly the speed that light travels at. And you'll see how in just a moment. Right, take off the wrapper. You have to take off the wrapper because the metal in it causes lightning otherwise. So in goes the first crunchy bar. I'm just going to put that about there. In goes the second. I'll put that roughly over there. Okay, so they're both on the plate, positioned a reasonable distance apart. And what we're going to do is we're going to give it a very short burst on the microwave. We're not going to give it that long at all. Okay, so off it goes. Right, okay, so let's open up the microwave, open it out, and you can see our crunchy bar has actually exploded in a couple of places. We've got a hole that's punched through the side there, and we've got another little hole that has emerged there. And what's going on? When you turn the microwave on, that radiation, that wave passes through the entire chamber on the inside. And microwaves interact with water molecules. They actually make water molecules vibrate, but only when they're microwaves are at a certain phase of their cycle. So it's not when they're at the peak, so when they've disturbed the magnetic field the most. It's not when they're at the trough, when they've disturbed the magnetic field the least. It's somewhere in the middle, but there's a certain part of their cycle that disturbs water molecules and makes them move, and makes them move faster. So as those waves come in phase with the water molecules, they heat them up. They cause the water molecules to bounce around, get a bit of energy, and that increases the temperature. Now the fact that we didn't let this plate spin round means that we're always heating up the same water molecules at the points at which those waves are in phase, in the correct part of their cycle. And we can see that we've got one hole here and we've got another hole here, and by measuring the distance between those, we're going to get a wavelength for our microwave. So let's get the old ruler out. Now it is a little bit tricky because you have to estimate where the centre of the hole is, as this is sort of sponged out. So I reckon it starts about there, sort of in the middle of that big melted mass, and it ends about there. So it's about 13 centimetres. So we've got a couple of bits of information here from our microwave. We've got the frequency, which was 2,450 megahertz. And we've now got a wavelength of 13 centimetres. So what I want you to do is I want you to use those bits of information gathered from my microwave, and I want you to calculate the speed of light.